user
Recording is on.
Recording is on. Okay, where the user is can use the credentials, and the difference is that with this new version where credentials are used, and this cannot be public, is because you have an extra feature here. You have a feature of personal notes where you can store your equations in order to use them backwards when you are making user-defined equations. And briefly now, I go for the remaining 10 to 15 minutes to some live demonstrations of the features of this tool. First of all, if we have the primary model, these are the outputs. And as you can see, it has all the classical features. You have the primary model, the Barani model, which is the built-in version. But I repeat, this is not exhausted only to the Barani model, but in the by default, for those users that are not familiar with different equations, you can set up the initial parameter estimates to help the convergence of the model throughout the observed data points. And then you have the window where you are estimating the primary model values like initial, final population, new max, and lag. Here, forgive me, there is a typo. This was the old version where everything was expressed in ln CFU per gram. Now the outputs, as you will see, are directly converted to log 10. Of course, the new max remains in the ln scale because it reflects the change of the ln population of the cells. So I will skip the video very quickly because I want to show you that in demo, but I just leave this to understand, to get a feeling of the tool as it works. You can use the tool either by introducing data in a file format or in a table format, by copy and paste from your Excel. And by pressing the fitting, then you can see here, you get automatically the results of the fitting. Now, regarding the secondary model fitting, again, we may choose up to different model terms. So we have, if you, for example, use a data set for temperature and pH, you can not only upload your data, but you can select which gamma factors are appropriate for fitting your data set. And then you can set the initial estimates in the format they appear in the equation. So you have mu ref, TAF minimum, TAF optimum, TAF maximum, and so on. And this is the outcome you get, or for more inhibitors. Let's see also a quick example. Okay, here, very quickly, you can introduce your data as copy and paste or as stored in a file with the same columns as though they appear here. So you can download an Excel template if you are not familiar with the format of the data that are used by the system. And here's an example where we have introduced the temperature and pH data. So you can select which variable to plot every time, temperature or pH. And then you can select which model to fit. You want the cardinal or you want the linear model. You want the cardinal model or the pressure model. And then you can apply the fitting, or you can apply the SQRT or log ln transformation of your new max if you want to stabilize the variant and create more precise conditions. And here on the right, you can see the estimates of the growth kinetics along with the standard error and some goodness of fit criteria. Okay, perfect. Sorry. And in the growth simulation mode, we have temperature, pH, and water activity plus 6 inhibitors. We can introduce them as average value or as a normal distribution with an average value and a standard deviation. And we can apply this transformation also to the cardinal values. This is the very important thing, because here, I go back, here you can introduce a strain-to-strain variation by introducing stochasticity not only on the independent variables like temperature and water activity and pH, but also introducing stochasticity in the growth limits. So you can describe the strain-to-strain variation. And as I showed you before, by introducing the cardinal limits as probability distributions, you can apply the same gamma models not only for growth, but also to derive the growth-no growth interface with a single hit. the same cardinal values are used both for growth and growth-no-growth interface simulations. So I go a bit further. Here you can select also which gamma model to use, gamma term for pH, temperature, and water activity to use, the Rosso model, the Ariani model, or the linear model. This is the type of the panel where you are introducing the input values like temperature, storage time, pH, water activity inhibitor, and you can also introduce them stochastically. So these are the average values, and if you let the standard deviation equal to 0, it means that you are performing deterministic simulations. But if you are using a standard deviation different than 0, then the system automatically understands that you are introducing some of the independent variables stochastically as probability distributions. And as you will see, you have the option also to set the number of iterations. And this is an unlimited number, but of course you have to keep in mind that the higher the number, the higher the memory capacity and performance, memory capacities of the system, which might gradually drop the performance. A very important feature, when we talk about CO2 in the package headspace, the user is asked to introduce a value between 0 and 100, but what the system does, it takes into consideration also the user-defined gas-to-product ratio, and through the Henry law, it converts the CO2 of the package headspace into a dissolved CO2 in the food according to temperature. So in this case, if you are using a standard deviation higher than 0, which means that you are uncertain about the true actual CO2 in the package, then the system calculates here and delivers the number of how many ppms of CO2 are dissolved in the aqueous phase of the product, depending on the temperature of storage, which is also given in the tool by the user. So this is a very accurate approaching. Instead of using only the CO2 in the package, this is converted to directly dissolved and equilibrated CO2 in the food. That is for CO2. And then when we talk about organic acid as inhibitors, the tool also offers this option that, for example, you can introduce the organic acids, first of all, in two different scales, either as ppm or as percentage units. You can introduce them fixed with SD value equal to 0, or you can introduce standard deviation of the inhibitors. Third, you can introduce them as organic salts or as directly total acid. So it depends on what you are thinking. If the industry wants to estimate the amount of sodium lactate that is added, then you can introduce the sodium lactate here. If what you're introducing here is not the organic salt, but is the total acid, you have to click on the AI input represents total acid. The system makes the conversions internally in order to take into account the proper value. And the cardinal values, as I mentioned, are introduced in a separate tab of the tool and can be introduced separately for pH, water activity, temperature, as well as for the inhibitors. And here you can see for the inhibitors, you have the option to introduce MIC, introduce the different exponents, okay, and give all the full details that are represented by the gamma term that I showed you before. And as you can see, you have a different tab for entering the input values, a different tab for entering the cardinal values. And the cardinal values can be introduced as single values or as probability distributions. In growth predictor, a normal distribution is understood by the software by adding a standard deviation higher than 0. This is the way that the system understands that. Okay, and somebody may wonder, if the system by default has Listia, how do I update the system requirements for a different microorganism? The answer is that you have a predefined set of database microorganisms. You will see that on a live. But you may also save the cardinal values that you introduce yourself here into a CSV file in order to upload them in the next exercise. So if you have stored many CSV files, and let me bring you to your screen. how a CSV file should look like. This is an example of a CSV file for Salmonella, where you have a list of cardinal values that can be typed by the user, either from the literature or experimentally determined, or even by any other expert consultancy. So by saving this file here and by uploading this file anytime in the system, anytime in the system through upload cardinal values, the system updates the information of the model about the different microorganisms. So it's totally adjustable for being applied not only for Listeria, but for any other microorganism, provided that you have a basic knowledge of the growth limiting or else the cardinal values. Okay, and sorry. Last but not least, because this is a very important feature, is that we have a new modules here. We have the inactivation and user simulation and the user-defined equation fitting. The revolutionary aspect of that is that apart from having a database model or a model from file, you may also use the equation editor. So by introducing an equation like that in the equation box, the system automatically understands what are the factors, the parameters or the variables that require an input. And then the user, by introducing proper inputs, either of the parameters like those here or of temperature and pH, it automatically generates the growth curve. And here I have left the option open to define whether this is an inactivation or a growth model. If you press inactivation, then the initial population will be high and the growth curve will be downward. If you press growth, then the initial population will be low and the inactivation curve will go high. So this equation editor is very, very important. So let me show you very, very quickly for the next 2-3 minutes, because we are just by the time of ending, but we start a little bit later on. So excuse me for this extra 5 minutes to show you a real demonstration for some critical aspects, and then I'm open to any of your questions. So this is the output of the growth predictor. I will guide you quickly through the major aspects. So this is the growth gamma simulation. So these are the simulations based on the extended gamma equation. Now, the good options here is that by manipulating the input values and having led the overlay graphs, it creates multiple graphs in the same window. If you don't like that and you want to keep only a single curve, you have to press this button. Here you are introducing the input values. I change the temperature, automatically I change the growth curve. And then I can go down here, I can add more inhibitors, introduce more CO2, introduce phenolic compounds, and you have an update. Now, if you go to cardinal values, you have the option to either use system values that are listed here, either upload values, upload an CSV file with cardinal values, or pick up from a database. And the database has a list of different microorganisms. Which ones? The ones that are shown here. So here on this window, you can see the cardinal values of different microorganisms. So you can pick, for example, Salmonella, you can pick Psychotrophic Lab, you can pick Bacillus cereus, okay? Or you can pick, for example, Pseudomonas and get a different response. And if you click overlay, then automatically by changing different organisms, then you get the relative growth of the one microorganism versus the other. But let's switch back to system values, okay? So, and let's click single graph. So I refer back to Listeria. This is where you are actually introducing your cardinal values. So by changing the cardinal values, for instance, of temperature, instead of 0.2.83, I make it 0.83. So you see the curve, it is updated. If I change the minimum pH value down to 4.4, for instance, okay, then the curve is updated. And I can always save these cardinal values, the new cardinal values, in a CSV format. Then I can call the CSV format later on. Now, regarding the stochastic behavior, the stochastic prediction, if I introduce A standard deviation for temperature 1 means that the storage temperature has an average value of 8.7 and a standard deviation of 1. But of course, I have one iteration, which means it represents the sample of a single iteration. If I make 1,000 iterations, 1 degree. If I make 1,000 iterations, then what you will see here, the system will repeat the same prediction with a band of 5 to 55 to 95 confidence intervals. And if I set a growth limit, a certain log increase, the system can tell you from to the time needed to exceed this value. And you can apply this for many different, you can introduce standard deviation for many different hurdles, like for example, for phenolics. So if you introduce more variability, then you will see that the bands will start to increase. If I introduce variability in the pH values for simulation, then you will see that you get more and more expansion of the bands. Let's make a more prominent example. So you can see now the bands really increase. Okay, you see now if I lower the pH, the phenomenon will be even more prominent. Okay, but what I can do also the same exercise with cardinal values, and I can I can update the standard deviation of the cardinal values. And in case of the growth inhibitors, for instance, here you have a list of different growth inhibitors. You can select out of different organic acids, okay? And instead of a normal distribution, I can also use a pair distribution. So depending how familiar I am with the description of the MIC of the different inhibitors, I can use a different distributions, either a normal or a pair distribution. And a pair distribution will ask you to introduce the minimum, the mode, and the maximum MIC value. So you have a bunch of different options in order to introduce. And this is the growth, no growth interface. So if I switch back to one iteration to save some time and resources. If I click, I have to click always a combination of two variables in order to get the interface. If I click more than two variables, one will be automatically removed because I get a two-dimension growth, no growth interface. So if I click, for example, here, pH and water activity, then I automatically get a growth, no growth interface. May I ask for the audience not to enter for the moment of demonstration into the tool because it is in our server and probably it creates a lot of burden. So here is the growth, no growth interface. And if I increase, for example, the concentration of nitrates, or if I increase the levels of CO2, then automatically the interface is shifted. And if I use cardinal values, for example, for the minimum pH for growth, then you will see that instead of getting a single line, we get a cloud of data points. And if I do the same for the pH, instead of having a 4.4 taking into consideration the standard deviation of minimum pH for growth, then you see that you get a cloud of data points because this accounts for the probability distribution for the strain-to-strain variation in growth limits in the minimum pH, for instance, or the minimum temperature for growth that represents the different Listeria strains. And finally, I remind you the example of the F-value calculator, where you can use a dynamic or a constant set of conditions. In all cases, you have to define a reference temperature and a d-value at this reference temperature and a z-value. So for instance, you can use a table to introduce your data, or you can use a file where your data, time temperature data, are stored. So let me go through this. Okay, this is the example I demonstrate to you in the slides. If you upload the time temperature profile in blue curve, then automatically the F value is calculated and the result is given here. So if a reference temperature is 70, but this is a wrong selection, for example, it could be 58, for instance, because the maximum temperature here is below 70. So you can see here that if you define the tough reference at 58, then this time temperature profile is converted as equivalent time at the reference temperature. And depending on the T value at the reference temperature, automatically updates the number of decimal reductions expected. Okay. And also if I update the the Z value, if I make it 6, then I have an update of both the equivalent time at 58 and automatically, since the time at the equivalent time at a different temperature is used, then automatically the number of total reductions is updated. And I can do that as many times as I want by manipulating the reference temperature, the D value of the reference temperature, and the Z value. And if you go to the inactivation and user-defined session, this is an option to select a microorganism from a database, and automatically the equation appears here. You can define whether you want to search for inactivation or growth models. If you change the food or if you change the microorganism, then you get an update of the food values available. Or you may start the other way around. You may start with the growth response and then see what models are available in the literature. Okay. And here is the equation, and here is the input value. And here is the interpolation interval. So the user knows within what range it can expect predictions. And this is what you get directly by introducing the duration of the storage and the initial population. And this is the physiological state. So if I use, let's say, slightly higher temperature, I calculate here the growth. If I change the physiological state from 0 to 2, then you will see that I get the formation of the lag time. I also increase the simulation temperature duration. And if I put, for example, a physiological state, now it's a bit unrealistic high value, then you get an extra lag time. So this refers back to the definition of H0 in the Barani model. Of course, you can use the equation editor, and in the equation editor, you can type in directly your own equation. So you can say point minus 0.002 times time minus T minimum, or let's say directly minus 1 degree if I know the T minimum, times 2. Okay, and this automatically understands that temperature is the independent variable. And by applying a proper temperature value and making a calculation, then it updates the graph. Apparently here, I have not used a proper value, let's say. Here you are. Since the minimum temperature was 1 degree, okay, I had used 4 degrees, so no growth. And here you can see the updated curve based on the user-defined equation. And here I can remove the lag time by putting a very low value of H0, and the growth is automatically updated. Now, if I want this to be treated as an activation model, all I can do is select inactivation, and automatically I will start with a higher level and I will end up with a lower. And as you can see, the model automatically is converted to an inactivation model. So you introduce here a secondary model that describes the impact of temperature on the rate, and you leave it up to the system to understand if you want to treat this model as a growth model or as an activation secondary model. So it uses actually the proper sign of the rate in the Barani model that is by default here, in order to convert the predictions of growth rate or inactivation rate into a change in the population. In the user-defined equation fitting, you can always also introduce a table with your own values of a primary or secondary model. You can rename a column, you can add a column, or you can remove a column. And you can always type your own equation here to be fitted. By typing the equation, the system understands which are the parameters and which are, depending on the column labels, which are the variables that are used as independent variables. And then you fit the model and you get the predictions of the estimation of the parameters according to the user-defined equation. So the user may store these equations to the personal node. For example, here I have stored the equation of Converse, and then I can simply type the equation in the box. So I can copy it here with Control C. I can go to the user-defined equation fitting. I can paste it here. But of course, if I use not new max, but I use X, Y as a factor, then I can rename the column, okay, as Y column, so that the system understands and perfectly agrees between what you write here in the equation, the left and the right part, and what your data show. And anytime, whatever equation you type, you can rename, you can edit the column names to match with those in the expression in the box here. And then you can apply your data in the table and adjust the parameters and press fit the model to use it for any user-defined model. So thanks for your patience. I took a little bit more of time, but I wanted to demonstrate in full extent all the available tools, available options of the software. Thank you very much for your attention.
So, thank you very much, Professor Panos. Thank you very much. Do you listen to me?
Yep.
So, thank you so much for this very nice presentation with a very good explanation on primary and secondary modelization in the predictive microbiology. And it's really good to see these tools are developed and that helps researchers, students, academics, and also professionals to apply the predictive microbiology approaches. So thanks again for all the efforts made to develop such a tool. And yes, indeed, we have some time for questions. But before that, I would like to kindly remind all the participants to fill the attendance form in order to get the certificates. So I will just now send it in the chat box. So please take a moment to do so. Now let's start with some questions that we have from participants. And uh, the first one is like a more broader question. Which type of user did you primarily have in mind when designing the tool? Researchers, assessors, risk assessors, students, or industry?
Sorry, can you repeat because I was trying to capture the question from the chat, but I could not see that.
Okay,
Can you
so
repeat the question? Yeah.
the question is, which type of user did you primarily have in mind when designing the tool? Researchers, risk assessors, students, or industry?
Hmm. In fact, I was very ambitious to try to meet as many needs as possible because different users have different needs. For instance, if you still see my screen, I believe that all the fitting features, the fitting modules of the tool are referring to more expert users. I wouldn't expect the people from an SME or a food industry with much low skills in predictive microbiology to be able to use data, first of all, generate microbial data or use data to fit these models. They would not, I would not expect even to understand which model to select. So in this case, the food industry, for instance, would be benefited, in my opinion, by very simple growth simulations or even growth, no growth models. So I believe that with proper fundamental training of the people of the industry, would be able to, for example, as I saw here, I keep using the software to answer the questions. So I would expect that, for example, if they type here their product characteristics, pH and water activity 0.95, they would be easily see how their product is placed in relation to a growth no growth interface. So for the food industry, I would limit in principle the application to very fundamental questions. So I would use the F value calculator because a time temperature scenario is always available for a industry performing a heating step. Now, again, the industry should at minimum introduce some TRF and DRF, but I know by heart, in collaboration with some Greek tomato product producing industries, that even if they are not modeling experts, and they are using some modeling platforms built in by their collaborators, they still are aware of some some D reference D values at a reference temperature for their target organism, whether this is Bacillus thermophilus, whether this is lactic acid bacterium or Zygosaccharomyces bailey. So they use them by heart or they use them without knowing the fundamental meaning, but they still understand that a process that gives a higher F value is a more lethal process than a process that gives lower F value. And they use this as a performance, as a process criterion or a process objective in their daily life. So they know that in order to be happy and safe with their products, they need to achieve a targeted F value, like a process objective. To do that and to validate that, they can use, I think, these features. Now, when we go to authorities, I would say that the authorities should first think like the industry in order to understand what people do and what the industry needs to demonstrate in order to prove compliance with the regulation, the micro criteria, for instance, or in order to set the shelf life, to do the date marking. When they think in date marking terms, actually they are thinking in predictive modeling terms. So they could do actually a kind of growth simulation with stochastic or deterministic terms and say the what if scenario, find the worst case and the best case scenario of the simulation. So they can go to the gamma growth simulations and be able not to do a growth, no growth interface, no longer needed, but actually do an exercise like that. They can test higher temperature. They can, for example, identify the safe food formulation. I would start from identifying the safe food formulation to the best possible way with the growth no growth interface, and then identifying the maximum permissible levels of antimicrobials that I could go, or the suitable pH and water activity that does not negatively affect my sensory properties. And then I would go to the growth curves, okay? And for example, say with this product, if I have a time temperature scenario like that I'm trying to populate here, okay? If I have a time temperature scenario and, for example, I have no nitrates or I have a very low amount of CO2, this is a real representation. I would say, for instance, if the limit for Listeria is 2 logs, if I assume I start with very low, I have a product that cannot get a shelf life, for instance, higher than 10 days. And then I can manipulate the shelf life. I can either set the date marking earlier than 9 days, or I can introduce more hurdles. For example, I can add more nitrates, I can increase the temperature, the CO2 in the packaging headspace so that I can get another 7 days of shelf life. So I think that these exercises can be performed both by the food industry with the proper guidance by consultants without having a lot of predictive modeling experience, but they can be also implemented by the food safety authorities in a risk-based thinking way. So they know what to expect from the food industry and they can use this type of tools in order to assess compliance of the food formulations with safety standards. I think the luckiest, of course, I'm a scientist, I'm a food scientist, I'm a food microbiologist, so my mind by default thinks in a scientific way. So the very first thing that I wanted to satisfy was the most demanding scientific person, a research person. What would now I've seen a couple of esteemed colleagues. I don't know if they are still there. I see Marcel Zwittering in the audience. I would like to satisfy a person like Marcel when using this software for teaching students, for instance, predictive microbiology. So what these people would expect as researchers to be able to fit data, fit primary models, fit secondary models, use the models to simulate the growth stochastically and so on. And the highest motivation was that, okay, the gamma-based models are really the ones that are used in the upcoming new ISO, which is about the estimation and use of cardinal values. So this new ISO will actually promote the use of this type of tools. But on the other hand, I mean, the literature existed before the ISO. So we have a lot of non-linear secondary models that are not necessarily gamma models. So my motivation was to be able to accommodate with equation editor the option for the user to test the outcome of the simulation of other non-built-in equations. Sorry for this lengthy approach, but I would say the same things in much fewer words that I was thinking as a scientist, what an industry would expect, an authority would expect, and a scientist would demand when driving this software.
Perfect. Thank you very much. So the next question is Growth Predictor a standalone software package, or does it require use of additional other software tools such as Combase, BioGrowth, and MicroRisk Lab to get the most out of Growth Predictor?
No, it's a standalone. That's a very simple question. The only thing that you can, I mean, the idea, which is relevant to the previous question, is, and this was recently introduced, is this option here. I found this very important. I mean, you can always use you can always use the database of microorganisms with their cardinal values, but maybe this is still not enough. So if you have your own cardinal values, then you can type them here, you can save them and call them anytime in the future. So the idea was to be as independent and self-standalone as possible, but with a minimum requirement that you have a knowledge of the limiting values if you are about to use the cardinal models and the gamma concept, because then it came to my mind that some people may not be familiar with cardinal values and they may only have equations and they have used them in their own studies. They may have even polynomial equations that would like to use. In this case, you are not constrained by the knowledge on cardinal values, and you can simply introduce your own equation here along with the parameters. You can store it in your personal notes so that you can copy and paste afterwards, and then you can type in your input values of the independent variables. So the idea was to have it as standalone as possible.
Okay, thank you. So the next question, are there regular updates foreseen, or do they primarily depend on input of the users?
Exactly. That's the correct approach. I mean, imagine that the software was primarily available for the first time, I would say 1.5 year before, but a lot of these points were not, a lot of these options were not available. And I started to make them available by appending more and more features, depending on the feedback by students, because I'm using it a lot at the classes, mostly of at the master level, and also in different webinars and in different workshops where I realized the need of updating some of the features. And it helped me a lot also to update a lot of the features based on the discussions we had with the working group. And one of them, for instance, this is a very good example as we are speaking. So, for instance, we were thinking whether the dependence on mu max on water activity is always linear and should have an exponent equal to 1. But then we came across uh, on this situation where we have the water activity, and the water activity is linear, but it has a curvature at the end. So in this case, I said that maybe we can go to the cardinal value or maybe the water activity with a curvature. And if I, sorry, well, what is the, this is an example where I have to inform the model with some features. So let's say that we have 0.91, okay. Okay, here we are. So we may have, for example, this case, by simply live in demonstration, okay, you see how I help the system by either fixing a curvature or by leaving the curvature open and manipulating or trying different terms, okay? So depending on the type of the equation, you may require different approaches in order to get the expected values. So I said that, for instance, in the original version, I had not included the N curvature for water activity linear model because most of the data sets that I had in mind were spanned between the minimum and a part of the suboptimal range of water activity that still the range is linear. Now, after the discussions we had with colleagues, we realized that we might also have some curvature in the upper part of the water activity values, and the proper modifications were made. This type of updates occur often depending on the feedback. The more people they use, the more people they are actually challenging the contents of the tool. They help me improve it. Although sometimes I get mad with myself because I say I should have thought that before, but receiving feedback is only constructive and more than welcome.
Thank you. Very clear. So the next question, how was the tool validated and what kind of experimental data are most suitable for validating its predictions?
Well, I think that regarding the growth simulations, we have also the option here to use. Let me show you. I'll show you how it is done, and then maybe the question will come out automatically. So let me go back and okay, remove the oxygen, remove the nitrates, make it as favorable as possible. You can always import data. Okay, you can, for example, let me show in, I think this is a nice set of data. I don't know how it will look. Okay, here we are. You can, this is nothing to do with this model because these are random data, but you can import experimental data, independent data on the same graph as your growth simulations in order to make a kind of validation. To me, uh, of course, you can also extract the model outputs in an Excel format and you can move away from growth predictor. You can take the outcome of the simulation, use it in your Excel file, and add as many columns of independent data as you like in order to see whether under the simulated conditions you get good agreement. To me, the most important is under what conditions you are calibrating the model to make it usable, realistic, and applicable for the different foods. And this relies a lot on what you are using here as cardinal values. And I would focus more, if I understood the spirit of the question, forgive me if I have misunderstood, that here, for example, you get the average, the mu ref, okay, and you also have the correction factor of the foods that we used also in the ISO document. So if your mu opt or your mu ref is calculated in a broth system, then you may have informations to update your value to the food by correcting the mu opt of the broth to the impact of the food matrix. So to me, the most important is what experiment you are choosing in order to update the parameters, particularly the mu opt or the mu ref, that calibrate your model to the food. Once you do that, you are increasing the likelihood of having a model behaving well. Any deviation might be due to uncertainty about the growth limits of the organism, or properly, or maybe with the improper selection of the data to estimate the conditions to estimate the mu ref or the mu opt, the correction factor that would calibrate the model from the broth system to the food. Of course, how to do that, the validation, one way to go is to upload your own independent data directly on the simulation graph. Another way, as I mentioned, is to do it the other way around, to extract the simulation data in Excel file and use it independently of the growth predictor. But the most important is how you can ensure that you will have a good response of the model to your data, how you would best describe the behavior of the target organism in the target food. And to me, this is not an issue of the growth predictor or of any tool, but it's an issue of the microbiologist who is trying to train these models for future use in the foods for the proper microorganisms. So it's a matter of wise and appropriate decision of data to train the model or of the source where you are getting the cardinal values.
Okay. So another participant asked, the lag time is often a critical and uncertain parameter. How is lag time modeled in the dashboard, and how should users interpret its biological meaning?
If I understand the question correct, the lag time, let me clear the data. Okay. So, and let's do a very simple example with the isothermal conditions. By the way, you saw here how I can shift from isothermal to non-isothermal conditions. So the idea of the lag time in growth predictor is introduced via the work to be done, if I understand the question correct. Huh? So here the work to be done is the H0 value of the Barani model, as long as we are using the default system, which uses the Barani model. If you want to use a user-defined model, then, if you want to use different than the gamma models, or if you want to fit a different model from the Barani model, then you can use the user-defined system. But as long as you are using the default system, which I found it quite practical, to be honest, and that's why it was my personal option and decision to keep the Barani model as the primary model of the growth predictor, you can manipulate the lag time through the H0 value. The H0 value takes values asymptotically close to zero, because by definition it's an LN transformation, so it does not accept zero value, up to theoretically infinity. But of course, infinity means infinite lag time. So usually, if we look at the scientific literature of food microbiology, and particularly predictive microbiology, we will see that the H0 values of most papers for, let's say, average most microorganisms have a range of H0 values between zero point 0.5 up to 3 or maybe 4. Of course, if you have a lot of injury, then you are expecting that the burden on lag time will be even bigger, and the H0 value should grow even bigger. But to me, the most important, and this is an example for students, because for the food industry, I would go to no lag time as the worst case scenario. Because how to quantify the H0 is a problem unless you have experimental data. What I have foreseen to do that, and I really like your feedback, not of course now immediately necessarily, but maybe in the future, I have given the option to use standard deviation of H0, so to describe the H0 also as a normal distribution. And in this case, I can work with what if scenario. And as you can see, by introducing standard deviation in the H0, you are somehow reflecting, let's call it variability in lag time, uncertainty in lag time, which is actually the uncertainty about the adaptation work, the H0. So you can use this in your simulations, and this is inherited, is transferable to all subsequent changes that you are making to the intrinsic factor. So the uncertainty in lag time remains as it is, and all the rest inputs are taken into account, the updated the lag time described via the uncertainty around the H0. I think this is a good approximation of our lack of knowledge about the true lag time under different conditions, because we are ignoring the history of the cells. And actually, the history of the cells is the most critical factor affecting the lag time in the new environment. And this is always a burden, this is always a problem. That's why I would defer more to the worst case scenario of no lag. But of course, for student and educational reasons, the option to simulate the lag time is also available here.
Very well. One more question. So you mentioned that the models, example, the gamma models should be calibrated. How can we best design experimental conditions to use the data with confidence in such complex models?
Sorry, once again, because the internet connection was not good. Once again, please.
Yeah,
Eh?
yeah. So you mentioned that the models, like the gamma models, should be calibrated. So how
Yes,
can we best design experimental conditions to use the data with confidence in such complex models.
Yeah, yeah. Well, I think the complexity is eliminated easily once we know the cardinal values. So the most important is to, if we are using gamma models, we should rely a lot on the or good knowledge, or let's say uh, the least possible uncertain knowledge about the cardinal values. Now, the calibration is theoretically done easily at the foreseeable storage conditions depending on which variable we think we should use as a reference value. Most of the times we are using reference temperature as, as a critical value that against which we calibrate the model to different foods, assuming that all the other factors remain optimal or do not have any additional impact. So we practically estimate a mu max with a primary model fitting, like the example I showed you before. So we construct an experiment where we are estimating a mu max, like the example here, the experiment is taking place, is incubation at the reference temperature of the product of concern. Of course, we cannot do, or there's no point doing an experiment at 37 degree because no food that is intended for refrigeration will be stored at 37 degree. Yeah? So we can use a temperature, let's say, of 10 degrees or 15 degrees, something that is not high enough to be unrealistic, but not low to be close to the growth boundaries. And then the mu max that we are using can be used in the growth simulations as a reference point. So it can be introduced here as a reference mu max. In other words, in order to calibrate the model, you need to be careful and select the conditions that are closer to the food of concern and making sure that you are only changing one condition per time. So you are calibrating the model versus a change, a reference change in a single environment. If you are working with growth data, you can estimate the mu ref at different conditions, but as you see in the note here, I invite you to see that if you are using different reference conditions for different gamma factors, this complicates things a little bit. And an answer cannot be given very easily. You need to take into consideration that you did not use the optimal conditions for all the other variables except for the one you used to estimate the MIC of an inhibitor, and you have to take that into consideration when you are simulating the model back. This cannot be done easily by a non-expert user. I provide some documentation in the tool, but of course this is something that we can discuss. In most cases, it is strongly recommended that you get a selection of a representative isolate from the environment of your food, and you are performing a challenge test at conditions directly in the food, making sure that the only thing you are changing is the reference, for example, temperature of storage. And then the mu max has a very high likelihood to properly calibrate the model directly to the food of your concern.
Okay, thank you. One more question. So, a participant would like to ask whether the old version of growth predictor is still work if available. Also, regarding the two-step validation approach following isothermal and then validating by external dynamic temperature dataset worth in growth predictor.
Well, the growth predictor, I mean, the link that is, if I understand the question correct, huh? The
Yeah.
link that you can see here, this is the link of the version that requires login with credential. There is also the other link that does not require credentials. Okay, this is the link that is available on the paper at the Food Research International. Every update, okay, by adding more features or removing or modifying them, takes place under the same link. So whatever update you may see in the future is still under the same link. So the first link is the lifelong link. There is no web link change with any update. So that is the original link that can be found in the paper. This is the updated link that can be found in your slides with a note that this requires credentials. And the reason it requires credentials is because we don't want to disclose what each single user will use as personal notes, and that is the reason that this version requires credential. But people are free to use this generic link, which is used in the paper, and the same link will always contain any future updates. So whatever worked in the first day will work the same way in the future. I don't know if I got the question or if it was a different concept.
Uh, I think you respond correctly the question. So one more, another question, please. Which equation could we use to predict the percentage of food contamination in order to compare it with international standard?
I'm not sure if I get the question. Which should be
Which
the
equation
percent?
could we
Yeah.
use to predict the percentage of food contamination in order to compare it with international standards?
Uh, if I okay, I'm not sure if I get the question or if it's a predictive modeling or a risk assessment question. But what I can show here, for instance, maybe I have not I can still not figure out the question, but I'll give it a try. Forgive me if I'm misoriented.
No,
So
no,
if for example I'm using a kind of stochastic simulation, okay, I will put 500 simulations iteration. Sorry. Okay, and if I have, I mean, I'll use a very high level, okay. And if I go to a 20, okay. Now, if I go to an example like that, I don't know if the question was about that. Of course, I can change the initial inoculation level. Now I started at the lowest possible. I can do it even lower in terms of log CFU per gram. So in this situation where the growth limit intersects with a stochastic simulation here, then the system returns to you the percentage of cells that exceed the threshold level, the percentage of samples that theoretically exceed the threshold value. So I don't know if the question was in this direction, but here you can estimate how much of the uh, uh, packaged individual packages are expected by the time that this simulation ends to exceed the threshold limit if you are using a stochastic simulation. Because if you are not using a stochastic simulation, then this is a yes or no. It will be exceed or not exceed. So if I remove the standard deviation, and there's no point having more than one iteration, this becomes a binary response that at the end of the simulation, the final population will be above or below the threshold level. But if you have a stochastic variation of this simulation, then it is likely that not 100 or nor 0% are above the threshold limit, but a percentage in between, depending on the width, the variance of the simulation.
Okay, so I think we have time for one last question, if it's possible. So, is there a database of reference D and Z value the
Uh,
industry can use for cardinal values?
Thank you so much. This is, for example, something that I have not included here. You see the feedback. Huh? Here I have only the growth limiting values. But what I usually, when I've done this webinar to our national food inspectors, and that was a question that I received from them. Huh? And especially when I show them the F value calculator, people tend to ask me, okay, how can I find the necessary information for Clostridium, for Salmonella? So the best approximation to resolve this issue was to add this supplement here. And as you can see in the example that I showed you, okay, in the list of cardinal values, you may also, I mean, this is a template, okay? And this template has a space for dref, tafref, and z value. And you can use as many CSV templates as you like by changing the name and upload them directly when you want to use the Z and the T and the D values. But unfortunately, in this database, I mean, in the built-in database of microorganisms, the one that can be accessed via the cardinal values pick up from database, the dref, tafref, and z values are not directly stored in the system. So this is something that I need to do in the future. The best approximation is to find them, save them in your own CSV, and call them later on by uploading them. But this is a good suggestion, to be honest.
Very good. Thank you very much, Professor. Uh, all right. I think we have addressed uh, almost all the questions. So if you have any more, please raise your hand or feel free to write them in the chat box now. But I think we have no further questions. So I think we can close this section, this today's section. Again, thank you once again, Professor Panos, for your time, for your very nice presentation, and for the enriching discussion. We are really happy to have you with us today. And let me please remind everyone that we will have another section tomorrow at 4 p.m. And anyone who would like to join us again or ask additional questions is very, very welcome. We look forward to seeing you all tomorrow. Finally, please, just 1 minute, we kindly invite everyone to turn on your cameras so that we can take a group photo to share on our platform. If you are comfortable, of course, please. Could you, Professor Panos, turn off the screen share, please?
Yes, yes,
Yeah.
yes. Um, Sorry. Um,
Thank you so much, Professor. It was a very, very good lecture. I enjoyed it very much. I'm sure everyone,
you're very welcome.
all of our participants gave very good feedback. Thank you.
Did I manage to remove the share screen? Is it okay?
Yes,
Yeah,
it's
it's
okay
okay.
now.
Good,
Um,
good.
Perfect. The participants who would like to turn on their camera, we invite you to do so so that we can take a screenshot and then post on our LinkedIn page. We'll wait some time. Good.
We are still waiting for you. Yes.
Okay. So smile, everyone. I'll take the screenshot now. Perfect. Thank you so much. Thank you. And tomorrow at
You're
4
very
p.m.,
welcome.
thank you. Tomorrow at 4 p.m., we will continue for a second session on the growth predictor tool. Bye bye. See you tomorrow.
All right.
Thank you.
Goodbye. See you
Have a
tomorrow.
good evening. Thank you very much for your participation and the active questions. Thank you so much.
Thank you, Panos. Goodbye.